Hey guys, how you doing? So in this video I just want to discuss some important questions regarding the Bode plot concept that we have been seeing so far. So here the first question I have taken from TSSPTCL 2018 AE examination paper. So the transfer function is to be found from this given asymptotic Bode plot of some open loop system g of s. So immediately upon seeing the Bode plot, go to the low frequency region. You are having a slope minus 20 dB per decade starting from this y axis or from the low frequency region. This directly indicates that you are having what? One pole at origin. So let me parallelly try to make the transfer function. You are having one pole at origin. Next, see where the slope is changing. Here the slope changes, isn't it? From minus 20 to 0. So what is the net change in slope? Net change in slope is 20 dB per decade. And what is that frequency changing happen? So 2. So 2 is a corner frequency. At this corner frequency you are having what? A first order 0 plus 20 dB per decade means 1 0. So let me make 1 0 also. So 1 plus s by 2. So this is the first order 0 and DC gain k. You have to keep it. Again look at here. Here there is a change in slope, isn't it? How much? From minus to 0 to minus 20. So minus 20 dB per decade is the net change. That means at 10 you are having what? A first order pole is present. Again look at the graph. Do you think any changes in slope is there? Yes, at this point I am having a change in slope. How much change in slope is there? Initially it was minus 20. Now it became minus 40 dB per decade. So what is the net change from minus 20 to minus 40? Minus 20 dB per decade is the net change, isn't it? That indicates you are having a first order pole at where? At 100. So let us try to make the poles also. So 1 plus s by 10. This is one pole and another pole is 1 plus s by 100. After simplifying you will get the g of s transfer function as 500 times k into s plus 2 by s into s plus 10 into s plus 100. This is the transfer function. Now you are supposed to find out the value of k. And I have already told you to find k, what should you do? First put is equal to, and after is equal to immediately put 20 log k. Okay. Now go to the low frequency region. Now low frequency region, what are you having? You are having a slope. How much slope? Minus 20. So put minus 20 log, and here you have to place some frequency, and frequency where the magnitude is known and that known magnitude on this side. If you look at the entire Bode plot, see at this 2 omega I am having a known magnitude as 4 dB. So put 4 over here and omega as 2. In Bode plots generally this term log 2 is commonly repeated, so it is very much essential for you to remember its value. It will be 0.3010. okay, so you are supposed to find 20 log 2. So what will be the value of 20 log 2? Approximately I can say it will be equal to 6. So upon further simplification I will get 20 log k equal to 10. So from this can't I find the value of k? So simply k will be nothing but 10 power 1 by 2. That means square root of 10. So what is square root of 10? 3.16. It is a direct value that we know. So put the value of k in this transfer function. So k into 500, that is 3.16 into 500 is 1580. If you look at the options, option C will be the right answer. Next question, I have taken this question from GATE Electrical 2019. Asymptotic Bode magnitude plot of a minimum phase transfer function is shown and is given you two statements and asking you to find which is true and false. The transfer function is having 3 poles and 1 0, that is statement 1. Let us see at the corner frequency. So if you first look at the low frequency region, you are having a starting only with a slope of minus 20. This indicates you are having one pole at origin. So if I make the transfer function, you are having s. Again see, is there any change? Here change is taking place. Slope is changing from minus 20 to minus 40. What is the net change? Minus 20 dB per decade is the net change in slope. That means at 1 what are you having? You are having a single pole. So that will be 1 plus s by 1. Again see, is there any slope changes? At 10 there is no slope change. You see the same slope is there, but here there is slope change which is at 20. How much change is there? From minus 40 it is become minus 60. So how much? Minus 20 is the net change in slope. That means you are having a single pole at 20. 1 plus s by 20. And there are no zeros, so simply k, DC gain k. So what are you having? You are having only 3 number of poles, but number of zeros are 0. So statement 1 is absolutely a wrong statement. So wherever the option is telling statement 1 is correct, that is a wrong statement. Now look at option C. Option C is telling that both of them are true, so this cannot be the answer. Again similarly look for A. Statement 1 is true string, so both A and C are eliminated. You are left with B and D. Next let us evaluate this one also. He is telling you that at a very high frequency the phase angle is minus 3 by 2. Minus 3 pi by 2. So let us see what will be the phase angle of this system. So let us reduce this transfer function further. You will get 20k divided by s into 1 plus s and 20 plus s. To find angle, put s is equal to j omega. So find g of j omega. G of j omega is nothing but 20k by j omega into 1 plus j omega 20 plus j omega. So can't we find the angle of this particular system? So angle of this system will be numerator angle minus denominator angle. Numerator is simply a real number, so it is 0 degrees, minus what is the denominator angle? Denominator you are having first minus just j omega, it is not minus, just j omega. Angle of j omega is 90 degrees minus angle of 1 plus j omega is tan inverse of omega. Again, angle of this one is minus tan inverse of omega by 20. He is asking you at omega tends to infinity. So put omega is infinity. At what value of angle you will get tan infinity? At 90 degrees. So if you try to execute, minus 90 minus 90 minus 90 is the total angle at omega is equal to infinity, that is minus 270. If you are supposed to write this in radians, that will be minus 3 pi by 2. So option or statement 2 is a right statement, okay, but statement 1 is a wrong statement. So option B is the right answer for this question. A Bode plot, magnitude plot is shown for a minimum phase transfer function. Find its transfer function. Again, immediately go to the low frequency region. You are having what? One pole at origin. Again, where the change in frequency is taking place, here the change in frequency is there. So minus 20 to 0. So plus 20 is the change. That means at omega is equal to 1, you are having what? A single 0 is there. Again, here you see there is a change in slope. So how much is the shift in slope? From 0 to it became plus 20. So net change is plus 20. That means at omega is equal to 10 also you are having a single 0. So if you make the transfer function of the system, the transfer function will have one pole at origin, but two zeros will be there, two finite zeros will be there at omega is equal to 1 and 10. So that will be 1 by s plus 1 plus s by 1, 1 plus s by 10. So these are the two zeros, DC gain k. So the total transfer function g of s into h of s equals to k into s plus 1, s plus 10 by 10s. Now you are supposed to find the value of k. To find the value of k, put is equal to 20 log k and go to low frequency region. You are having minus 20 dB per decade slope. So minus 20 log omega whose magnitude is known. So if you take omega is equal to 1, the magnitude is 20 dB per decade. So 1 and the magnitude is 20 decibels. 20 log 1 reduced to 0. 20 is equal to 20 log k. That is log k is equal to 1 means k is absolutely equal to 10. When I put k is equal to 10, 10 on numerator and denominator get cancel. You will have s plus 1 and s plus 10 by s, which is option 2. That is the right answer for this question. A system is having 12 poles in total and 2 zeros. Its high frequency asymptote in its magnitude plot will have a slope of. He is asking you to find out what is the frequency of asymptote in its magnitude plot, and he did not tell you what kind of a pole is it. Then let us take it is a poles or zeros at origin. So the transfer function will be having 12 poles at origin. That means s power 12, and it is having 2 zeros at origin, s square. What will be the net order of the system? Or net system will be 1 by s plus 10. So you are having 10 poles at origin. One pole will produce a slope of how much? Minus 20 decibels per decade. Like that you are having 10 poles. So minus 20 into 10, which is minus 200. Option C is the right answer for this question. Consider Bode plots, magnitude and phase both are given in this question, which is taken from ISRO EC 2017. Of two different open loop transfer functions. You are basically what you are trying to do is you are having a open loop transfer function. After reading the question, you will get this conclusion. It is an unstable system because it is having poles in the right half of it. Now you are adding some feedback mechanism to this, and you got some closed loop system, and you are supposed to find what is the stability of this system. So there are two example systems, system 1 and 2. For the both of them, Bode magnitude and phase plot is given. Based on this, you are supposed to find or judge the system stability. So in frequency response, we have defined two different types of frequencies. What is called as omega PC, other one is called as omega GC. What is omega PC? It is the frequency where the phase angle of the system becomes minus 180 degree. And what is omega GC? It is the frequency where the magnitude becomes 1, or if you want to find the magnitude in decibels, it becomes 0. That is called omega GC. For the system to be stable, omega PC must be always greater than omega GC. So this is the condition for stability. So if you look at the Bode magnitude plot, this is the magnitude plot and this is the Bode phase plot. You see where Bode magnitude plot is becoming 0, that frequency is omega GC. See, the magnitude is becoming 0 decibels at this point. So this point corresponds to omega GC. And look at the frequency where the phase angle is becoming minus 180. This is the phase plot. Here you got omega PC because there it is becoming minus 180. You observe PC and GC. Which omega is higher? Omega PC is greater than omega GC. So this first system is a stable. Come to the next system. So this is also here a magnitude plot. Here magnitude in decibels is taken. This is the phase plot. Look out where magnitude becoming 0 decibels. So here magnitude becoming 0 decibels. So this is omega GC. Look out for phase where omega phase is becoming minus 180. So this is minus 180. Omega PC. What you are having condition here? Omega GC is greater than omega PC. That means directly I will tell this is unstable system. Then look at the options. You will have option A will be the right answer for this question. Thank you for watching.